Thanks for the kind introduction. Yeah, today Proventia is delighted to show what we do have an offering for the future demands on the non-road mobile machinery towards zero emissions, and also not only to decarbonizing the emissions or CO2 free, but also the local regulated tailpipe emissions and how these are going hand in hand. So tomorrow's EAT systems and electrification, we see them as a tool towards zero emissions or CO2 savings fuel economy, and we have developed both of these component or tools into our toolbox. I'll utilize time to introduce our company with the first couple of slides. Those who may know Proventia yet, we are a Finnish company. We do provide after-treatment systems. We provide different type of technologies on the engine development and machine development. So you will hear some basics on the Proventia. And then we discuss on the green transition drivers. What are the drivers today towards lowering the emissions or environmental impact on the off-road? And especially on our side, emission control and thermal components and batteries at the end. So these are the three main components we provide. Proventia has a vision zero emissions for many years already. So it's not only for this bauma exhibition purposes. We have had this company vision for a long time. And for us, that means we help our customer base to reduce their emissions. But at the same time, we take our part, we do our part also seriously, and we minimize our emissions in our own processes. Yes, Proventia is a Finnish company, established in 1994, close to 30 years already. And we have been growing despite of these weird years during the COVID time, during the current crisis in Ukraine. We have been able to expand our sales or increase our sales and also the manpower. So our customer base has been successful, and we gain the benefits, of course, out of that. We have been profitable all the time throughout the years, despite of these challenges. We are not one of the biggest ones, but we are growing quite fast. So I started 5 years ago. I was employer number 45. Now we are 170 in total. Headquarters is in North Finland, in Oulu, 200 kilometers below Santa Claus. And we have R&D facilities in Finland. We have some of the manufacturing sites in Finland, and sales people are also there. Then we do have a factory in Czech Republic, nearby the Brno. There we do the EATs for the OEM, European OEM customers. And then in addition, we do have a sales office in UK, and outside Europe we have local partners, naming India, Turkey, that kind of areas. We have a local customer service partner and assembly partners. Those who were listening Volvo Penta's presentation, that was very nice presentation on the importance on the collaboration on all the aspects. We need everyone towards green transitions and towards zero emissions. So it's not only the engine development or fuel development or just reducing the use the energy. It's the whole picture, and we need all these aspects. So regulators are, of course, main drivers for doing something better in tailpipe emissions, but also with the CO2 target. Most probably we will see that also in off-road in coming years. So energy efficiency and CO2 reductions are on a daily discussions and as a daily tasks. From environmental point of view, yes, and also from economical point of view. Different type of fuels together with the diesel are developing. Diesel is still the primary today. There will be a lot of alternatives. Liquid fuels like HVOs or e-fuels are coming. Then we do have a lot of gaseous fuels as candidates. Let's see what of these will be the dominator, but nevertheless, fuel needs to be improved. And then electrification at the end helps a lot on the green transition. Proventia provides mainly, basically 4 different type of technologies. Test solutions, mainly for the portable laboratories, testing powertrain components, electric components, engines, and engine components up to vehicle dynos. So we provide portable test solutions on different purposes. I will not speak on that too much today. But then for the clean machinery, our solutions are emission devices, EATs, complete systems, and also at the component development level. Then we do have thermal components, mainly insulations, and then we have developed battery packages for the hybrid demands. So these are the three main parts of our offering, which I will discuss today in more detail. Starting with the emission control, we have been focusing on the off-road throughout the company's existence. We do mainly OEM business with the off-road applications. We do have some retrofit on the road. And by having this kind of focus always been in our strategy to focus on the off-road, that has been assuring that we know what the field demands, what are the field expectations. So we have a very good design and engineering expertise, especially on the off-road application purposes. Compact design, very harsh environmental environments, wide operation window, wide engine load windows, difficulties at the light of on the forest machinery, somewhere in the Finnish Lapland, minus 40 degrees, and so on, and so on. Not only EAT, we have developed now complete system together with our partners, so we can provide turnkey solution, including dosing components, tanks, lines, ECUs for the AdBlue injection, and all the components which are needed and which are shown on the picture here. So it's not only the canning of the catalyst today. So we can provide the whole kit if customer wants, and there are some areas where, and some application types which this seems to be the winning solution. Like I said, we have a long track record on non-road mobile machinery. We have seen most of the headaches during the development, what they might be, starting from the uniformity challenges or temperature control challenges, mechanical challenges, lot of vibrations and so on, dust collections on the wrong places. So this has been seen during the decades, I would say. Proventia is also, we target to get benefit out from our size. So we are seen and we know that we are one of the most agile company in making the development. We listen carefully what customer really wants, and we do have a quite lean development process. We have everything under the same roof, from simulation to prototype to testing, and so from the simulation to testing throughout the manual proto works, it takes only a couple of days if we are having a capacity at that specific moment. So we are agile and efficient in development and also in serial manufacturing. Stage 5 examples, who are our customer, what kind of customer bases we do have. Construction machineries, mining machines, agriculture, different type of agriculture machines, and forest machinery. And here is some of the examples of our stage 5 layouts. Inline, it can be located outside of the engine bonnet on the vertical orientation, or more or less the same product can be located on top of the engine under the bonnet. Major part of the parts are the same. There are some differences in the fixing parts, of course, and different type of U-shape designs. This can be seen in our booth. This is visible at caller stand and so on. So all these layouts can be seen in bauma as well. Like you see, different type of layouts, different type of applications. Those all are based on our in-house mixers. We have developed 3 different AdBlue mixers, 2 for the end can purposes, starting with the Tornado, And now the latest one can be seen, or it's not seen, but it's inside the green tractor shown here in the hole, one of the holes. And our basic technology on the mixture is that we inject into the swirling curve. We enhance the evaporation of the AdBlue. We allow customer to inject much more than most of the others, meaning that mixture itself is very important part of the complete picture towards fuel economy as well. The better the mixture, the higher the back pressure. That's true. But the higher dosing amounts can be used, the easier to calibrate the engine to maximize the fuel economy on the other side. And we know that these mixtures are helping customers to make their calibration. First of all, none of our stage 5 customers is using EGR today. So we are able to handle up to 9 to 10 grams per kilowatt hour NOx emissions, and still in the real world, no deposit issues on the field. What's next? What's happening after stage 5? Should be maybe the question mark. We have heard a lot of stories, and we have seen a lot of, if you go throughout the exhibition, especially if you discuss with the engine manufacturers, there's no readily available solution. There's no final rules yet, but everyone is focusing into developing to be ready on the different technologies towards beyond stage 5, EP 8 year 5 and European stage 6. Best guess is that it will be implemented somewhere 28, somewhere 2030, somewhere there, meaning that the development projects are already starting. And there, like I said, there's no official rules frozen yet, but most likely DPF will be needed also at the smaller engines, even below 19 kilowatts. That's one thing which most likely will come. And another issue is that SCR will most likely to be needed also below 56, like today, even below 37 kilowatt engines. So compact SCRs will be needed, compact DPF housings will be needed because the engines are still quite compact. Also the applications are compact. So these new regulations are enhancing the importance of the compact design and right type of components to be used. From emission control point of view, we believe, and based on the discussion with our customer base, we believe that combustion engine will remain for the non-road mobile machinery, off-road machines, as a dominator, as a primary source to move the engine and make the work done. With the improving their tailpipe emissions, but especially on their fuel economy, and this is something what everyone is focusing on. Regulations, yeah, they are tightening. The engine need to be improved. Components after the engine need to be improved. There will be various type of hybrid systems, batteries, hydrogen, liquid fuels on different manners, and we believe that emission control components and emission control technology will remain still. It's not full electric in coming decades. So which of these two one should focus? CO2 or regulated tailpipe emissions? Easy question would be, of course, both. And that's actually the real answer. And those are not something which are opposite to each other. Those need to be handled at the same time. The better the after treatment is, the easier to calibrate the engine, meaning the better fuel economy customer base, engine manufacturer can find. Most probably, the next legislation will we'll have a DPF, like said, also in the smaller engine. For the NOx, limit will be much tighter than today, even be like 10 times more tight, meaning that there will be more demanding, higher demand for the SCR, NOx conversions up to 98-99% from the raw emissions, and at the same time fuel economy is there, so how to calibrate the engine, what kind of SCR is needed. Most probably there will be twin SCR similarly to automotive Euro 7. We'll discuss that a bit later as well. Engine raw emissions, baseline emissions, like said, can be up to 10 grams per kilowatt hour today. If you put EGR again on the engine, yes, it's easier to meet the NOx emissions, but then how about the fuel economy and how about the CO2 target then? There will be new components to be regulated. N2O might be the most probable one, ammonia another. And this N2O limit will mean a lot of different type of challenges to be tackled by engine manners and by after-treatment manners. What kind of dosing accuracies we can provide, what kind of catalyst chemistry is inside on the systems, what kind of temperature controls are there to handle that there's no N2O to be measured as a too high amounts. It's not too easy task, I would say. And of course the test cycles and homologation approval studies, those are of course very important. How much those are changing from today? Most probably, and obviously there will be colder cycles, cold start emissions as a focus, meaning a lot of challenges. Meaning insulation, thermal components need to be improved as well. Exhaust gas must be heated up by the way or other earlier than today before it goes to the tailpipe or after-treatment systems. How to make these? Traditional way, DOC, DPF and SCR and put the EGR there again. That might be okay, that might work, but then we have an issue with the CO2. And at the same time, how big the SCR can be. Is this enough to meet the next regulations? Probably not. That's why people are discussing and everyone is developing twin SCR. Twin SCR means there's two different SCRs, one in the nearby the engine as close couple position, and then the main SCR like today. Lot of questions to be handled and a lot of new challenges to be tackled. First of all, chemistry most probably cannot be the same as today, so the coating companies have their tasks. Do we need and can we put oxidation catalyst in front due to thermal mass limitations point of view? Can we inject into the flex element? Because after the engine there's a piping with the flex elements to buffer the vibrations. Can you have a flex element if you have already injected AdBlue into the pipe? How about the control of these injections? Is same injector enough? Same dosing control unit accurate enough to control both? Or do they need to be separated? Is the injector, are the injectors today on the market good enough for the, and are they durable enough for the nearby the engine, accurate enough on the smaller dosings and so on? And together with the new injector types, also the mixture need to be considered. What kind of mixtures are there? And if we have a twin SCR, how much we can provide downsizing of the main SCR? That's also something need to be studied. So like you see, all these lines are having question marks at the end. That means that there's no ready solutions. Everyone is focusing on the development. And let's see, it's interesting to see in next 2-3 years what are the outcomes of this heavy development everyone is doing now. Of course, the more compact the EAT, the drawbacks for the emissions, CO2 emissions, because the back pressure is also increasing. And I would guarantee that it's not cheaper if you put more components and more intelligence inside. We have done some kind of concept development already. These are illustrative concept layouts, different type of closed couple mixers. It can be mixers at the end of the end can mixer or through the end can mixer. It can be really the new designs or also the mixers into the pipe or inside the pipe. And like you see, there's a different layouts if the main closed couple SCR is immediately after the mixer or is it as part of the main canning. These we are studying at the moment. So the future EAT will look something like that, most probably for the off-road. Let's move ahead. Let's go to the insulation for a couple of minutes. For us, the thermal components insulation means we want to keep temperatures inside the pipes due to cold start demands, keep the exhaust gas inside, help the catalyst works, allowing customers to inject AdBlue as soon as possible from the engine ignition. But at the same time, we want to keep surface temperatures in control. There's more and more sensitive components inside the engine room. And of course, the better the insulation is, the colder the surface is, the less harsh environment for the connectors or wire harnesses or different type of sensors. Also here in insulation, we have experience from the off-road market quite many years already in this area, like mentioned. So we have insulated our own EATs. So the catalyst package itself has been insulated by us, and more often all the pipes are insulated, and turbochargers and even exhaust manifolds are insulated today on the latest applications we have developed. So that also helps in the low temperature performances. Different type of insulations. It can be like modular heat covers to make the surface temperature or keeping the temperatures in control in a rather simple way. Mostly often we provide readily shaped heat shields on the certain parts, and naturally the different type of EAT housings are insulated by us. Then let's move on to the batteries. Proventia has developed our own battery package for hybrid purposes. We are not focusing on the full electric EATs, but we are focusing on helping customers to hybridize their machines. First of all, we have selected lithium titanate oxide, and that's because we want to provide high power batteries instead of energy storage batteries. So this chemistry, lithium titanium oxide, is helping customer to release the power fast and recharge equally fast. So it's perfect for the high peak demands. Basically, if you have a 6-cylinder engine now, you could maybe downsize the engine to the 4-cylinder, and then you get from battery additional tens of kilowatts you would need for the peak power demands. LTO itself is very safe, so it's perfect for the construction machinery or off-road applications. It cannot be burned, basically. And we have expertise in EAT design. We have utilized that expertise also in the battery packaging design. So we have designed the housing by ourselves, which is surely robust enough for any kind of off-road applications. Two different packages. ePro 48 is containing 20 main batteries, LTO batteries, and it's like a base module that provides 40 kilowatt peak power, and it's like a 30 kilo in weight. And you can come to our booth to see that and listen our specialist in more detail on the battery itself and the packaging. And then multiplying these base elements, we can provide for the hybridization for the larger applications like mining trucks, for example, and so on. So we see that there's no one type of solution fits to all. So we believe that there's a lot of diversity in future. but sustainable combustion engine with the alternative liquid fuels, most probably we will see those in the market in coming decades for quite a long time. At the same time, different types of gaseous fuels are coming, hydrogen combustion engine or hydrogen fuel cells, or which is not mentioned here, biomethane combustion engine similarly. If the biomethane is fossil-free, then the emissions are also quite clean from CO2 emission point of view. And different type of hybrid systems are coming for sure. So a lot of things to do, and KGP as a consulting company making market studies and technology trend studies, they are seeing that in coming 30 years, half of the off-road machines will be fossil-free or zero emission. So we are on the right way, but it takes time. And on our way, when we are there, before we are there, we have a lot to do to getting the next stepstones during our way. So green transition is opening new business opportunities to many of the players on the industry. For us, it of course means the batteries, insulation, EATs, and test solution as well, testing the new components on the electric development. And there will be a continuous development needed in the engine side and also in the after-treatment side. Having said this, I'd like to thank you for listening and welcome to our booth to discuss more. Thank you.